Okay, so today I'm just want to work on algorithm, and of course we always practice my English skill, speaking and communication. Okay, so communicating. Okay, I am on like a code signal with I have a time set up. I need to finish in 60 minutes for 6 questions. I know maybe I cannot doing that in 30 in how how long? I like 45 minutes with but the time of code signals they give me to end in 2 hours, so I have been on the second question number 2 of 6. So I want to just record myself and how I talk about solving problems. This is just let's get started. Okay, this is the binary problems, binary trees problems. So giving a binary search tree, return the value of the orienting node. When there is a violations, return the lowest node. Lowest node. If there is no violating node, just return one. The property of binary search trees are that what is mean violating node. The left subtree of nodes contains only nodes with key less than node's key. The right subtree of node contains only nodes with key greater than the node key. Okay, so the right subtree, both of left and right subtree must be the binary search tree. A warranting node occur when one of those properties is not met. This means, for example, we have three binary search tree. We have like a root node, right? And they are left and right. So usually, when the binary search tree is correct way, it have to be on the left, should be less than the root t on the right, should have greater than the root trees. And then if we find something is greater, like let's say on this example we have a node root t at 5, and then left is number 2 and the right is number 10. That is correct, right? But then because of the node of number 2 is like a root, right? There are children, and then there are number 8 and the number 2. That's also is mean wrong because we have so this means we return 8 because the variations we have variations between 5 and 8, and because of s is not less than number 5, and then because of s is the lowest node, it means the last one, right? So that's why we return 8. So what I'm going to do here, I'm going to create a variable to hold the lowest one. So let me just call it name violation node value. That's what I'm gonna set to -1, and I'm going to return violation node. And then to solve the problem with problems with binary trees, what I'm going to do, I'm going to use a recursive function call. So I'm going to have a function traverse, which gonna traverse to the left and the right, so accept the root node, right? Okay, so and then I'm going to call at first time, so we want to call traverse with the root. Okay, and then we know that when we work with recursive function, so we need to have base case, right? So my base case will check if node is no. If node is no, we just return, and then our function will just stop working. And then okay, so sorry, I need to have like other variables to hold to store the prep value as well. Prep value node. Okay, so that's one I'm gonna set to like the minus infinity with the lower ones. Okay, this is like how to say, like the lower first number in the number type. So, and then inside function traverse, what I'm gonna do, I'm gonna travel to the node left first. So I kind of call traverse is like recursive call. So then I say node travel to the left. Okay, and then we also gonna travel to the right as well. But between to the left and the right, that's what our logic's gonna have here, our algorithm we're gonna have here. So I'll travel to the left first, and then I'm going to check if the values from the node, right? If node app values is less than the prep node, we're going to reassign by validation nodes from subtract 1 to be another values as well. So let me check here. So our logic will be we travel to node that left, and then we're going to check if prep nodes value which we set to minus infinity is greater than node dot value. That's what we do something. Okay, if prep values is greater than node dot values, and then we're going to do something else. If the value is not greater, right? If the prep value is not greater than the node dot value, we want to reassign prep value to node dot value. Okay, and in the if locals function, I mean in the if, that's logic gonna do here. We want to check if violations nodes is equal to -1, which should be correct because we set to subtract 1, right? And then if so, we want to reassign validation node to be our prep node. Okay, and then when we reassign prep nodes, what we want to do, we want to find the maximum between variation node value and the node value. So I'm gonna reassign variation node, and then we use the math.max, which is come from JavaScript, and then we compare variation nodes with node value. Okay, and that's it. Okay, so let me just try to run to see if my code is working. Okay, let me just work through here again. Okay, the functions we do is that we create a function, right? So the function to check violating values. So it means if you find something is not met with the left and right, which should be binary search. If they are not, so we want to return the number of the node, the value of the node. If otherwise, if we didn't find anything, we return -1. So I do declare we say variation node value is set to subtract 1, and then I have the other variables which called prep period node value is set to minus infinities with the most low ones, right? And then we have we define our functions. We're gonna be recursive functions. So what I'm doing here, I have like a check. We know like a recursive call, we need to have our base case. So we check if it knows. What we do, we just return nothing, and then we traverse to node the left. So and then when we travel to node left, and then we check if prep value node is greater than node dot values. If so, we want to do something by reassigning the nodes, the validation node. We're going to check if validation node is equal to subtract 1. What we do, we reassign prep value to the validation node, and then outside of this if, we want to find which one is greater between validation node and nodes that value is returned from the node while we travel, right? And then that's in if. And else we want to do like reassign prep value to the node value. So we assign to node values to the prep node values, and then after that we need to travel to the right as well. So we travel node to the right, and then if we find something, we choose return validation nodes. We already reassigned our logics inside our function, recursive function. So let's run to see if our code is working. Okay, it's past test. Thank you so much. Bye.